Hi, I'm Clara. I'm a graduate student in the Fin Lab at Dartmouth College, and today I'm going to be presenting on an ongoing project in which we look at how we can use a narrative to explore shifts in neural representations. It's not uncommon for us to consume or interact with the same media twice. We often rewatch our favorite movie or reread our favorite book. So this then introduces the question of how we process the same stimulus when we're approaching it with differing viewpoints or differing prior knowledge. And oftentimes, the majority of past research has looked at this by exploring how groups of individuals reach variable interpretations of the exact same stimulus. And what we're interested in here is actually how the exact same individual is able to shift between interpretations, and we use the term reappraisal to refer to this shift. And what we're interested in here is how do individuals process the same stimulus but with differing information. So if I'm engaging with the same stimulus twice, how am I reprocessing or reappraising the exact same sensory information so that I wind up seeing it differently? So how and where do neural representations shift with this reappraisal process? And can I identify these shifts at the level of the individual? We had subjects listen to an auditory narrative while they were being scanned in an fMRI scanner. In particular, this narrative is a podcast episode from the podcast The Truth, in which participants listen to two people interacting. And this interaction is contextualized in the middle of the narrative in the period that we call the twist, such that pre-twist, participants think that the two characters are just talking in the bridal shop, while post-twist, they learn that the female character is in fact a robot, preventing the male character from escaping an apocalyptic setting. And the goal of choosing this stimulus is that listener perceptions of the story and of the characters should drastically shift as a result of the disambiguating information provided by the twist. So to get at this, to get at how individuals' ratings of characters may be shifting, we also had subjects engaged in a continuous rating task as they were being scanned, in which they needed to indicate how positively or how negatively they felt towards the female character / the robot. And please note that we did not necessarily expect assessments to be consistent throughout the narrative, nor did we expect all individuals to have the exact same perception of the character. Participants listened to the same narrative 2 times, and of course on that second listen, they did have access to the entirety of the disambiguating information throughout the entire listen. Participants then engaged in a recall period after each listen, and at the end, they were given the narrative to read outside of the scanner, and they had to mark the twists and the moments that they wound up reappraising or reinterpreting on that second listen. So this was particularly important because we were then able to use the individually defined time points to get at the twist. So what you're looking at here on the x-axis is time, while on the y-axis is the proportion of subjects reporting that a twist occurred at a particular time point. And we find that the twist was reportedly confined to a range of around 250 seconds. And what we can then do is that we can determine the twist at the level of the individual, i.e. treat the twist for each individual subject, or at the group level. And for the purposes of this presentation, to keep things simple, I'm going to use group level defined twists, which you can see now, and we use a conservative estimate of time points that subjects call the twist to determine the 3 segments of the narrative: the pre-twist segment, the twist itself, and the post-twist segment. I also want to note that subjects reported the location of the scenes that they reappraised on the second listen, and all of these scenes were located in the pre-twist segment. Thus, we felt pretty confident that the most interesting differences would be in this particular time period. So just to specify, what we're interested in here is how the twist may be driving shifts in interpretation. And to do that, what we could do is actually compute similarity between listen 1 and listen 2, or between segments of listen 1 and listen 2. And what we would hypothesize is that there should be high R, or high consistency, or a high correlation in the post-twist period, as subjects do not have access to new information on that second listen. However, we would expect low R, or low correlation, in the pre-twist period because subjects should be processing the pre-twist segment completely differently on the second listen in light of what they learned or how the information was contextualized during the twist of the first listen. And in order to actually compute this similarity or compute these R values, we're using a model-free time-locked approach that is popular in naturalistic designs called inter-subject correlation or ISC. And in this case, what we're looking at is a similarity in neural segments across individuals as they're listening to the stimulus and generating a similarity matrix for listen 1 and for listen 2 to be able to answer questions such as how similar are people in the pre-twist and the post-twist period for each listen, and where in the brain are people actually similar. So to look at that, we end up finding that a cross-participant similarity is overall higher post-twist, as indicated by the green in the brain plots that you can see here. So purple here would be regions where there is more consistency across people within listen in the pre-twist period, while green are regions where there's more consistency in the post-twist period. And we see that in the majority of the brain, with the exception of the superior temporal sulcus, there's more consistency in that post-twist period as we hypothesize. This is in particularly seen in a lot of association cortex regions, including regions that have been previously reported to be involved in memory and interpretation updating, such as the inferior frontal gyrus and the temporal parietal junction. Notably, the magnitude of the difference in correlation is a lot lower in listen 2, which could be due to repetition effects or could be suggesting that there may be more individual variability in terms of subjects are reprocessing or reappraising the stimulus on that second listen. So with that in mind, we can pretty much conclude that the shifts does seem to drive a cross-subject similarity. But then we can start to ask questions such as if we can see commensurate results at the behavioral level. So here's an example subject's continuous ratings of that female character. And as expected, we see low R or big differences in people's behavioral assessments in that pre-twist period across listens, and high R or high consistency in that post-twist period. So that's very commensurate with what we're seeing neurally in the majority of regions. However, what we also see objectively is that there is a lot of individual variability. So what I'm showing you here on the left-hand side are 3 additional individual subject time series, and you can see that there's a decent amount of variability in terms of the degree of difference in the pre-twist versus post-twist periods between listen 1 and listen 2. So then we can ask, are we able to actually capture how individuals may shift their representations? So to do that, we think it's actually more interesting that rather than taking the canonical inter-subject correlation approach, but it's more interesting to actually take an intra-subject correlation approach, such that rather than looking across participants within listen, we can look within participant across listen and see specifically how similar is a participant to themselves between listen 1 and listen 2. So how similar is my temporal parietal junction to my temporal parietal junction between listen 1 and listen 2? Has activity sort of shifted in light of interpretational differences? So here we can ask how consistent individuals are by generating intra-SC maps for each individual and then taking a bootstrapping approach and plotting the median values. And that's what you're looking at here within segments. So we can see that pre-twist participants are most consistent with themselves in sensory regions and the superior temporal sulcus. This particularly makes sense given the fact that this is an auditory stimulus. We also see that the degree of consistency or similarity is much higher in the post-twist period. We see overall higher similarity across the brain. But then if we formally test this, as I did for the across similarity analyses, we find that the effects follow, such that there is majority of the brain shows higher similarity in the post-twist period, as indicated by the green, but the regions that show the strongest effects continue to be the ones that we saw in the across-subject similarity, and those are regions that are associated with the default mode network and previously reported to be involved in memory updating and attention and interpretational shifts. So again, we see effects that are commensurate with the inter-subject effects, except they're much stronger. So then at the behavioral level, we know that there's a decent amount of variability, but when we take an intra-subject approach to the behavioral time series, we end up finding that the majority of subjects are more consistent post-twist and pre-twist, again in line with our hypotheses. So just to conclude, what we're showing so far is that we had subjects listen to the same dynamic narrative twice. This narrative presented disambiguating information in the middle that drove discernible neural and behavioral differences. These differences were especially seen in that pre-twist period, suggesting that participants were shifting their interpretation of the stimulus, and neurally this was most strongly seen in regions that are associated with the default mode network, in line with a lot of previous prior work. And with that, I want to note that I have no conflicts of interest to report, and that the slides may be updated by the time of the meeting, so please reach out for an updated version if you're interested or if you have questions. Thank you very much.